Hello, we are continuing our study of dynamics, and today we are going to talk to you about what the friction force is. This is another one of the popular forces that we meet with you in this section, and one of the forces that is necessarily present in our world. Our task today will be to study this force, to see what it depends on, and to understand what laws describe the resulting friction between bodies. So, what is the friction force? In the world, there are a lot of phenomena when the friction force either prevents or promotes movement. That is, it is impossible to say unequivocally that the friction force will resist the movement of bodies. Often friction is a direct mover of various objects, and we can analyze with you some phenomena that we see around us. For example, ask yourself the question, why can you walk on the ground? That is, your task is to move from one point to another. At the same time, we send an impulse from our head to our head and to our legs. The feet start to move while pushing off the ground, and our body moves in some direction. Now, it is important to realize that it is the frictional force between the surface of your foot or your shoes and the surface of the ground that contributes to the meshing of these two objects and helps you move in the desired direction. In this case, we can talk about the fact that there is some kind of frictional force that contributes to your movement. Here we are talking about a type of friction called rest friction. Rest friction is a frictional force that keeps bodies from moving relative to each other and works when bodies are not moving relative to each other. There is another friction force that occurs when bodies start sliding one on the surface of the other, and we call it sliding friction. All these are examples of interaction of two surfaces with each other, and our task today will be to see what laws describe this interaction. Let's start with the first situation, where there's an object on, say, a horizontal surface. And our task is to move it. What do we do for that? To do this, we apply a certain attractive force in an attempt to move it out of the way. What happens if we fail? In that case, the velocity of the object will be zero. And this motion will be hindered directly by the friction force that occurs at the point of contact between this object and the surface on which it stands. That is, there is a friction of rest. So we can label it like this. And this friction does not allow this object to move. If it doesn't move, then the friction force will be compensated for by this traction force. And it doesn't allow this object. Gradually increasing the effort, we can notice that at some point in time there will be a dislocation of this body from its location, and its rest will turn into movement. In this case, we say that the friction of rest has changed into sliding friction. And at this moment of time, we can say that the rest friction force will pass smoothly into sliding friction, and here our task will be to show what the rest friction force depends on, its maximum value. That is, at each moment of time, the rest friction force will be equal to the traction force. And here we just need to know about what force is acting on this object. In this case, we can enter a value that will show when this breakdown will occur. This value is called the static friction coefficient and will show the ratio between the friction at rest and the reaction force of the support that occurs between the given object and the surface. So in this situation, when we talk about static friction, we need to take into account the nature of the interaction of these surfaces. That is, it will depend on what surfaces are interacting, whether there is lubrication between them or how well they are polished. All this will depend on the given coefficient and accordingly the support reaction force, which acts in this case from the surface side on the given body. These two factors will determine the resting friction that's going to be to prevent the motion of the object. But in this case, if we are talking about the maximum friction force, then naturally, and we're talking about the maximum coefficient of friction. So what happens when the motion starts? Let's look at the second case, given that the body has now started to slide. That is, in this case, our velocity is not equal to 0, and here different variants are possible, i.e. there can be uniform motion, i.e. the body slides uniformly on this surface, or the body can accelerate. It is generally not important, because the most important thing is that the body began to move. And then we're talking about the fact that there's friction of motion, what we call kinetic friction, and this friction force is going to impede the motion of the object. If we talk about why this friction occurs at all, then of course we should pay attention to the fact that these are all forces of intermolecular interaction. That is, these are the forces that arise at the junction of two bodies and are the forces of entanglement of individual molecules for each other. That is, certain parts of these bodies are closer to each other than the rest, and they enter into this very intermolecular interaction. Due to this, the bodies begin to catch on these roughnesses, and further movement is already accompanied by certain difficulties. Therefore, we can attribute the friction force to the electromagnetic force, as for example, the weight of this object along with the reaction force of the support. These are all forces of electromagnetic nature, and our task now is to describe the sliding friction force. In this case, it will also depend on the coefficient of motion friction. So in this case, it's moving friction. And it will also depend on the force of interaction between this body and the surface. These coefficients of friction may differ, may somewhere be very close to each other, but in general, in each individual case, we must consider this situation separately. We can consider a graph of the dependence of the friction force that occurs between a body and a given surface, and the force that sets this object in motion. So what happens in the initial phase? When the body is not yet moving, static friction is acting, and the friction force and the drag force will be equal to each other. This tells us that we have this graph at a 45-degree angle, ensuring that these two forces are equal. And all of this happens until this body is pulled out of place. We're just talking about this point in time when the resting friction reaches its maximum. This resting friction will reach its maximum, then it will decrease a little bit after that, to a value where the friction stops changing. What we can say is that the maximum resting friction here will be at the top of this graph, and this is the value when the friction has stopped changing. The traction force can continue to increase, but the friction force will not change. In this case, we're talking about the sliding friction force because it depends directly on the coefficient of friction. It depends only on the given surfaces and on the support reaction force. That is, it is already a fixed value which will not change further. So this is roughly what a graph would look like of the dependence of the friction force on the traction force that we applied to this object. So we have considered the first and second cases when frictional forces are obstacles to the movement of an object. But we have talked about the fact that friction forces not only can prevent objects from moving, but they can also help them move. What would it take to do that? If you and I consider a person who starts to move calmly, then in order to ensure that we move forward, that is, to create a certain amount of acceleration, we want to change our speed from 0 to some value. We need to push off from some surface. In this case, the horizontal acceleration will be imparted by the friction force that occurs between the human foot and the surface of the ground. And that is, the backward movement which we make when we try to push off the ground automatically reproduces this friction force. And that friction is because our foot in this case is not sliding on the ground if the grip is good. Due to this friction force, there is a positive acceleration for our body. In the same way, we can talk about the motion of a car, which also has the ability to move on the surface of the ground, because its wheels in this case, rotating in the same direction, they've got a grip on these points. At these points, and that friction is going to create the necessary traction. That is, when we talk about the traction force of a car, first of all we must understand that it is nothing but static friction between its wheels and the ground. Here we show a situation where the car is four-wheel drive, that is, both wheels are moving wheels. Further, our task will be to consider concrete situations in practice and to study directly how these laws are applied to the solution of problems. The main here are the formulas, I repeat once again, kinetic friction and static friction. It is them we will use in solving problems, and necessarily we must understand in each case how this friction will be directed and what role it plays for a specific case. Once again, I repeat that friction can both hinder and promote movement, so it must be taken into account in every task. This is the end of our theoretical part. We will see you in practice. Goodbye.